Hey guys, and welcome to Unit 3, Part 2. We are going to continue in our unit on sensation and perception and focus on more of the different things that go on and different effects and different things that kind of alter and change our perception and what we see. So the first thing we're going to talk about is attention. You guys know what this is. It's just focusing on something, you're paying attention. You're kind of zoning out on everything else besides one specific thing, or maybe multiple combined together. Selective attention is more so when you're focusing on a super specific thing and completely ignoring all others. If you guys have ever tried to play Marco Polo in the pool when you were younger, you probably, if you were the one calling out Marco, you probably try to zone out all other outside noises and listen for the people to say polo. Cocktail party effect. This is where you are hearing specific voices. And so if you are in a large crowd, let's say homecoming, and someone calls your name, usually you will hear that. It's very interesting, and if you try it, if you go to the grocery store and call your parent or guardian by their first name out of a large crowd, they're more likely to turn around. And then one of the other ones we have is a very strange phenomenon. It's called the Stroop effect, and some of you guys may have already seen this example, but I'm going to show it to you again, just because it is, it's always entertaining and challenging, but it's the way that we automatically read a color name, but when we put the color and the words in two different fashions, so the color of the word in one color, but then the word that's written is a different color, it messes with our brain. And I know that sounded very backwards, but you'll see it on the next slide. And feel free to give it a try, see if you can do it. This is the Stroop effect. Again, the way that automatically reading a color name can make it difficult to name the color in which the word is printed. And this is where, even if we try to use selective attention, it can be very, very difficult. So if you look on the left, as fast as you can, name each color of ink used to print each of the rectangles below. So you have your yellow, red, green, yellow. Then if you look on the right side and do the same thing, and you're going to name the color of the ink. So red, green, yellow, blue, yellow, green. It takes so much more effort. Attention is shiftable. So a lot of you guys are driving or learning how to drive, or have at least hopefully paid attention while someone else is driving. This is a great example of paying attention, or just attention, and seeing how it's shiftable, because you need to pay attention during specific times. So another example with the selective attention is when you're driving. You can listen to music, you can talk to people and have a conversation, but if you ever get lost, you turn that volume down so low, or possibly even the radio off, roll up all the windows, turn down the air conditioning so you can focus on the directions and make sure you don't get more lost. With attention, we also could have emotional stimuli, so specific words that could be little triggers. So depending on where you are or what you see could alert you for a different reason. And then inattentional blindness is the failure to detect any events when you guys are usually engaged. If I had you guys watching a basketball game and you needed to count how many basketballs pass on the screen, you might not notice someone in a gorilla costume walking across. Stuff like that. Perceptual set is a predisposition or readiness to perceive something in a particular way. And this is usually better for older people. However, we have seen that children, because they haven't solidified their perceptual sets, they can be really good at this. So there was an example with a bus, which if you are listening to this, make sure you draw a bus somewhere on near this box in your slide notes. But they had a bus and it looked like it could be going either way on the screen, and you had to determine which way it was going, and 90% of kindergartners got it right, and like 20% of adults got it right, which was pretty cool. Sensory adaptation. This is a change in the responsiveness of the sensory stems based on the average level of surrounding stimulation, and this usually takes time. Examples are you're blind right after you turn off the lights. Your eyes haven't adjusted to see where you're going, and vice versa. In the morning when you turn on a light, you're like, oh my gosh, what's happening? Freezing when you first get into a pool, but give yourself a minute or two and you're fine. A Band-Aid. Usually when you put a Band-Aid on, you feel it for a few moments, but then after that, you're like, oh, I forgot I even had a Band-Aid on. We are going to be going into how the eye looks, functions, how it processes in the brain, different colors, and how we see color vision, and how we even perceive shape, depth, motion, and constancy. Which these are all super cool, and if you are in art, this is probably a review for some of you guys. So we have light, and if you're in physics, this is probably helpful as well, but it's a form of electromagnetic energy, and we can see that in wavelengths. It travels through space in waves, visible from 400 to 700 nanometers, and it determines hue or color. Wavelength is the difference from the peak of one wave to the peak of the next. Amplitude is the height of the waves, and it determines the brightness of the stimulus. And purity is whether all the waves are the same or different, and that could mess with your perception in a way. And here's just a little graphic of where you see your color and other things in comparison. And that is the last of our slides. I hope you guys have a great evening, and we're going to go into more of the notes on the eye.